Hey guys, welcome back to another episode of the Mind Muscle Connection podcast. Today I have a very special guest on the episode today, Calvin Scheller. So real quick, he is setting the record for the youngest guest here at the young age of 19 years old. Super impressive. He's a super smart guy. He had numerous articles in Alan Aragon's research review that caught my eye. And he's been PubMeding since the age of 13, and he's pursued a scholarly understanding of the biosciences ever since. 13 years old, man, when I was 13, I'm telling you right now, I was not looking at anything related to PubMed or anything like that. So that's super impressive. He just wrapped up studying bioprocess technology, and he is also doing online coaching as well too. So Calvin, thanks for hopping on today, man, and looking forward to chatting with you.
Yeah, absolutely. Thank you for having me.
So like I said to you beforehand, I did want to dive into, your background and what you're doing now. So if you don't mind, just briefly sharing that, and then we'll go from there.
Yeah, so I guess my background starts right around the age of when I got into everything. So for when I was a little bit younger, I was a little bit overweight. I'm still a healthy kid. I loved playing sports and stuff. And then around the age of 13 or 14, I developed an autoimmune disorder. I had some pretty bad IBS for about 2 years to the point where it was tough to eat anything, let alone frequently, if that makes sense. So I didn't know what foods I would react to. And just eating food in general was always, you know, it was always interesting to see what would happen afterwards. So I had a lot of gastrointestinal issues for about 2 years. And in that period of time, I ended up losing about 40 or 50 pounds. I'm not the biggest guy at the moment, but I was about 40 pounds lighter at my lightest. So I was about 5'8", 5'9", 108, 109 pounds. So I was in and out of doctor's offices and in the hospital for a little while just to keep everything stable, if that makes sense. So it was it just happened out of random. It wasn't really anything that I controlled or was expecting, but it definitely sparked my interest in understanding human physiology a lot. So I had nothing but time because I was in and out of doctor's offices. I was out of school a lot. And then it was right around the time where the entire pandemic happened. So I was at my house a lot with basically nothing but a computer. So I also, as a child, didn't have any television or video games. So it was go outside or read something. And I decided to read a lot. So I was about 14 when I really started diving. I read a little bit of science when I was around 13, but it was around the age of 14 where I spent hours a day trying to. First, it took me a while. It took me hours to get through a single article because, as some people may know, when you first dive into an article, it all seems like gibberish or a foreign language. You're stopping every other sentence to look up a word or try and get more context onto something that the scientists think that you should know or the people that are reading it should know. But when it's your first time looking into it, it's definitely tough to get through. But it was just a self-teaching process. So it took me a few months to feel comfortable getting into articles. And then ever since then, I've always got my nose in something. So if you look at my Google history, it's just a bunch of PubMed searches and stuff like that. So I've been really fascinated with human physiology for 5 or 6 years now. And that led into me starting to help people that I knew with weight loss or body composition goals or preparing for sports for the school year or something like that. And I had a few people that had some pretty good results and the word got out. And I started helping more and more people and writing articles and being on podcasts. And at that point, people asked me to start making content of my own. So that's what I had decided to do. And over the past 2 years, I would say, I've probably got about 1,000 videos on all social media platforms, and they're growing every single day. And I've had some crazy opportunities the past few years to be on podcasts like yours, writing for Alan, and just a bunch of opportunities that I couldn't even imagine when I began with just trying to figure out what was going on with me, if that makes sense.
Yeah,
Um,
no. Oh, sorry.
no, go right ahead.
I was gonna say, no, that's super awesome. And yeah, again, just doing it at such a young age too, I think is just super impressive as well too. Is there I know you said obviously you dealt personally with IBS and stuff like that. Is there anything from a human physiology standpoint that you're like really like the best, or is it just pretty broad from that perspective? Or is it more just like kind of body composition type stuff, weight loss, things like that?
Yeah, I'd say personally, I really enjoy endocrinology. At the time when everything happened, when the rapid weight loss happened, I had a lot of endocrine issues. So I was in and out of endocrinologist offices for a while, and understanding different things that dictate how hormones function or how much you are producing of them, or things that can inhibit slash promote the expression or production of specific hormones. That's always been where my fascination lies. I did a lot of work, especially with writing articles on things like cortisol, the thyroid. I've done a little bit on insulin resistance, which is one of the things that got me a little bit more popular and got me onto a few podcasts was that subject specifically because it's so pertinent to everyone. But I think understanding endocrinology and how things function and how I can interpret blood work to understand what's going on and find solutions. That's always been a little bit more top of mind than how we can get as lean as possible or as strong as possible, things like that.
And there's a lot of misinformation around all those things as well too on social media and in the fitness industry in general.
Yeah, absolutely. I would say that I had to unlearn a lot of the things that I learned at the beginning from podcasts and social media throughout the past few years. I think I've done just as much unlearning as I have learning, if that makes sense.
Yep, absolutely. Cool. So then for you, what do things look like now? I know you do some coaching. What do you see your future in fitness and in this field kind of being? Are you going to try to pursue more of the academic side or yeah, what does that look like for you?
Yeah, so it's an interesting question where I'm at right now. I don't portray it much on social media or if at all, but social media is like 1 to 2% of my daily life. So outside of social media, I have 5 jobs at the moment. So I'm back and forth from different locations. So I work at 3 gyms, a restaurant, and then I have a full-time job at a manufacturing facility, which honestly I really enjoyed. I've been more than likely am going to end up moving up there and essentially doing that job and social media alongside it. So trying, and if social media blossomed into something where I could make it into a full-time career, whether that be coaching or making content or teaming up with a company or something of the like, then that's something that I'm open to, if that makes sense. But I think what I have going on social media is like a very small portion of all the other endeavors that I engage in. And I've also been for a year or two after once I got my biotechnology degree, trying to get into the cancer research field, have a few interviews lined up with that. Whether or not social media ever became a full-time thing, I'm not quite sure yet. I think I'm still playing it by ear, but I'm working hard at the moment elsewhere, and I'm putting all I can out on social media and supporting myself with that. And then again, I'm just playing it by ear at this point. I'm loving what I'm doing right now, so there's there's not much of an impetus for me to make any drastic changes, but still trying to pursue each endeavor with as much effort as I can give it.
Yeah, no, I think that's awesome, especially with you being 19. It's you might as well. I think too many people probably try to figure out like this is exactly what I'm going to do, and it's like you said, you didn't think you'd be doing a lot of the stuff you're doing now. You're just getting experience, right? Putting in the reps, and I think that at this age, man, that's like the best thing you could probably do, and that way you figure out what it is that you eventually want to do. So I think that's awesome that you're keeping it open and doing multiple things. So it sounds like potentially the fitness thing might not necessarily be like your full time gig, but right now it's part of it. But you also really enjoy your work outside of it as well too.
Yeah, absolutely. And I think as I produce more and more content, I see how people react with it and engage with it, and I'm learning more every single day. So I'm no professional at it. So I think if it ever got to the point where I didn't have time to do all the other jobs or even one other job with all the things I have going on social media or coaching, that would be the point where I'd be able to transition into some sort of a full-time content creator or coach, if that makes sense.
So it sounds like then in terms of like fitness research and stuff like that, probably not the route as of now. Like again, you did mention like cancer as being something, but again, from the fitness side, sounds again, probably not going to be the route, at least as of now.
Yeah, I think I've got options, so we'll see what happens. But hopefully, I can get more into the honestly into the writing side of things if I can, being a part of the publication process, whether it be on cancer or another subject. I'm working on a PubMed article, an article in a journal that will end up in PubMed right now with a few people. So that'll be a stepping stone to further my kind of research and academic career. And then whether or not I go to school to continue pursuing that, again, it is dictated by some of the opportunities I get these coming years. But I'm glad to know that I have a lot of different options.
Yeah, that's awesome. Can you tease on what the topic is that you're going to be publishing?
Yeah, so it's with some of the bigger names that I could think of, at least in the exercise science space. And it's I guess the broad topic is all about muscle hypertrophy, not necessarily the tactics to grow muscle, but how much muscle can be gained over a set period of time.
Awesome. And when do you think this will be out? And yeah,
I think we're shooting for next year. The exact time next year, I'm not quite sure, but we're going through all the data analysis right now, and then we'll have some big names on the writing process.
awesome, man. Yeah, that'll be sweet. Again, hypertrophy is another topic where a lot of misinformation out there. So I'm sure it'll be nice to get something like that out there as well too. And it's always evolving too. I feel like there's just a ton of research going on, but it's also very time intensive as well too. Yeah, man, really enjoy all your stuff, and that's awesome. I feel like you're just getting started with everything. So looking forward to seeing more stuff come out in the future there. So cool. One of the articles that you actually wrote for Alan Aragon was around appetite. And I think this is an awesome topic because what is there again, just with a lot of stuff, there's a lot of misinformation. And again, you really dive into the science of it. And I think it's fascinating. The article you had, the title of it was The Fascinating Physiology of Appetite Regulation. And I definitely think that title is true. So wanted to bring you on and chat about that in more detail. So if you could maybe just give like a brief overview of appetite, like what it is, and then we can go from there.
Yeah, so I think appetite for me has always been a little bit difficult to describe just because it doesn't necessarily always mean food. You can have appetite for a multitude of different things. It can be for food. It can also be for, you can have a social appetite. Some people may find that they have appetites for alcohol or specific types of food. Sometimes at its worst, it can blend into appetite for drugs. If you're anything like me, you might have an appetite for caffeine. So a lot of different things that you can have an appetite for, but it's essentially the desire to consume something. And within that, there's also a lot more nuances. So it appetite is, in a sense, what if you and I both went to a buffet, what would dictate how many calories I ate versus how many calories you ate. But appetite will also dictate the specific foods that you or I choose to eat. So there's different subsections of appetite that can become very nuanced, but in totality, it would be the desire to consume, and that can be a lot of different things. And it's affected by a multitude of different things, whether it be taste, actual need for body fat, or lack of need for body fat if you have excess body fat. So it can be dictated by your last night's sleep, your current blood glucose levels, so dictated by a lot of things, but it's your desire to consume food and what that thing might be, or sorry, desire to consume and what that thing that you are consuming might be is dictated by a lot of different factors.
What are like some of the things that you see portrayed on social media, like maybe where people get it wrong, or what are maybe some misconceptions around appetite that like you typically see if someone just thinks of it just very generally and whatnot?
Yeah, I think a lot of times on social media, we see very simplified explanations for things. So blaming a specific hormone for why you're hungry, or a specific hormone as dictating your appetite. So people will talk a lot about things like insulin. There's a lot of obscure messaging about insulin on social media, as a lot of people know. And one of it is some people have the hypothesis that insulin stimulates your appetite. So insulin is something that makes you more hungry. And when in reality, we see elevations in insulin after a meal are one of the most important factors for suppressing appetite. So those who have the largest insulin spikes, or the meals that increase insulin the most, tend to actually have the most satiating effects rather than the least satiating effects. So there's a lot of kind of simple talk about specific hormones as governing everything, and that's just not quite, it's not, as you might have seen in the article, there's probably tens of, not hundreds of different hormones that might be dictating appetite, some of which we might not even know yet. But there's a multitude of things that will alter your appetite, and blaming it on a specific hormone, especially insulin, is a little bit, it's a little bit missing the mark. And then some people will focus, as the advent of new weight loss medications like Ozempic and Wegovy, who mimic the production of GLP-1. So they bind to the GLP-1 receptor and activate it the same way that GLP-1 that we produce in our intestinal tract would. People will point at things as they raise GLP-1 and indicate that they would be just as effective as something like Ozempic and Wegovy, which we see has extreme data for being very efficacious for weight loss. So we're talking about the magnitude of GLP-1 release, the duration in which GLP-1 is released. So it's very difficult to compare foods or beverages or even supplements to one of these, probably the most powerful medication we currently have for diabetes. So I think getting very granular on specific molecules or specific hormones and missing the bigger picture.
Yeah. So like you said, not blaming just one thing. Again, it's just there's a lot of different things going on, and people will try to isolate the problem to one thing when really that makes, for example, insulin the bad thing, and it's okay. Again, there's multiple things going on here. It's not just insulin. And I think too, but also I think maybe that blaming it on, say, a hormone or something like that, I feel like sometimes it takes like for some people, it makes them think that, oh, it's not my fault, or there's nothing I can do about it. I guess not my fault's not the right word to say. It's more, there's nothing I can do about it, when there are some things that we can do that are going to impact our appetite and whatnot. And I think that's part of it is well too. So I know one thing you mentioned too is, so what is the primary regulator of appetite? I think this is something that people probably don't understand and forget, don't realize as well too.
That's a tough question. I think there are so many regulators of appetite. So a lot of the regulation of appetite occurs from hormones, essentially different hormones and neurotransmitters that have either what we refer to as anorexigenic or exogenic effects. So anorexigenic meaning appetite suppressive, and orexigenic meaning appetite stimulating. So a balance of a multitude of different hormones will dictate whether or not we do or do not want to consume food. And there are also other things that will dictate food, even if we are not hungry in the terms of we haven't eaten, but we may see something that we know tastes extremely good, and we get the release of different molecules that would also stimulate appetite. So appetite isn't ever driven by a singular molecule, and it sometimes is driven by a subset of different molecules or the lack of specific molecules. So appetite is very hormonally dependent, a lot of which comes down to how much food you've eaten over the day, how much body fat you currently have, and then the foods in your environment. And then there's other things that we don't really think about too much that also can dictate appetite, such as how well your sleep is, your current mood, how much water you consume that day, and things like that. So there's a lot of different levers that will play into appetite that it's hard to really pin it on a specific thing.
What's the brain's role in appetite?
Yeah, so I will say the brain is one of, if not the primary regulators of appetite, in the sense that it will dictate whether or not we go actively pursue obtaining food. And it will also dictate which foods that we consume. So sometimes, although our stomach may be full, our brain is dictating, or our brain is almost telling us that we want to go consume a specific food, but not any food. So it might be, we might have a craving for a food that's very palatable, that we really enjoy, but we might not have a craving for a food that is unpalatable but maybe nutrient dense. So we may go choose to eat a cookie, but at that present moment, you might not be able to put down a bowl of broccoli or a big steak. So the brain it remembers things that we've consumed in the past that may or may not have satiated our appetite or curbed a craving that we had. And that is part of what dictates what we decide to consume. And then the specific, essentially our physiology at that given moment will dictate our desire to consume something. So whether or not we are hungry, very hungry, not hungry at all, things like that. It lies on a spectrum.
Gotcha. Cool. And then leptin, what is leptin's role in appetite?
Yeah, leptin is one of the biggest regulators of our appetite. So leptin is a hormone that's produced by our fat tissue. So the more fat tissue you have, the greater your fat mass, the more leptin you are producing. So someone who is 10% body fat would produce less leptin than someone who is 20% body fat, given that they're the same height. So the person with the more poundage of body fat will produce the most amount of leptin. And it has a multitude of different roles. There's actually more and more research coming out as leptin being an inflammatory mediator and a lot of other things that we don't really think about a lot when we speak of leptin, but its biggest and most popular role is going to be appetite suppression. When leptin is released from the fat cells, it can travel, it can get into the brain, and it can bind to receptors in the brain that reduce our appetite. So hearing that, one of the biggest things that leptin was thought to do, it was thought to be the cure for obesity. So we would just essentially give people leptin injections, and they would have more leptin floating through their bloodstream, because obviously the idea was that obese people must be deficient in leptin. That's why they're consuming so much food. But when we decided to begin injecting people with leptin, we saw that for 99% of the population, specifically the obese population, it didn't really do anything. And the reason is because it appears that, as mentioned, the more body fat you have, the more leptin you're producing. So obese people, or people who have excess body fat, they have more than enough circulating leptin. The problem is that when leptin is binding to its receptor within the brain, it's not acting the way that we would expect it to act. So we would refer to this canonically as leptin resistance. Essentially, we are producing enough leptin, and there might even be leptin receptors available, but when it binds to that receptor, it almost is as if that receptor doesn't function anymore. And there's a multitude of different things that can play into leptin resistance, but one of probably the biggest thing would be excess production of leptin. So it's a phenomenon we refer to as homologous desensitization. Essentially, when you're producing too much of a specific molecule, that your brain or body begins to become less and less sensitive to that molecule. So the more leptin we're producing, the less sensitive our brain is to that leptin, which means that people who are overweight and have excess body fat, they have just as large, if not larger, appetites than someone who is at very low levels of body fat, despite producing a ton of that appetite suppressing hormone, because they are no longer able to essentially sense the amount of leptin in their bloodstream.
It sounds very similar to insulin as well, too, right? Where it's the same kind of concept there as well, too, right? It's you produce so much of it, again, your body can become desensitized to it, right? And then the same thing happens with insulin resistance as well, too, correct?
I have a few videos, and one of the biggest articles I wrote for Alan was on insulin resistance. And there's a misrepresentation of insulin. So it doesn't appear that insulin actually acts through the same mechanism. So it doesn't appear that insulin exerts homologous desensitization on all of the cells that have insulin receptors. What actually seems to happen is there are two main things that drive insulin resistance. The first is when a specific cell accumulates too much intracellular fat. So essentially, a cell has too much fat inside of it. Specifically, it starts typically inside of the fat tissue, which is our main storage area for fat. And once our fat tissue become overfilled with fat, they become insulin resistant. And some of this fat begins spilling out into the bloodstream and can begin being deposited in other places, such as the organs or the skeletal muscle. And in these locations, it will also induce insulin resistance of the liver, of the kidneys, of the skeletal muscle. So it appears that insulin resistance is primarily driven by having excess fat on the body, especially in specific areas where we wouldn't want it. So the storage capacity for fat in the liver and the muscles is much lower than the storage capacity for fat in the adipose tissue. So even small depositions of fat in these tissues can induce fairly rapid insulin resistance compared to the fat tissue. So the two main things that drive that are one, having excess body fat, and physical inactivity. So not moving enough decreases the amount of those fatty acids that we're burning, which means they're more likely to accumulate inside of a given cell. And the other thing is actually inflammation. So inflammatory cytokines have the capacity to essentially bind to specific proteins inside of cells and then induce those cells to also become insulin resistant. So some of the most fascinating research is the idea that tooth infections can induce insulin resistance transiently because of an upregulation of the production of these inflammatory mediators. So it doesn't, and that's one of the things that is one thing that I've tried to combat a little bit is the idea online that anything that raises insulin, so any consumption of carbohydrates, would induce insulin resistance because we have the conception that it also functions through the same mechanism, where it doesn't actually appear like that's the case.
Gotcha. Yeah, super interesting stuff, man. Is there any other like big ones that you want to hit on or anything like that we've missed so far from an appetite standpoint?
Yeah, I think as much as I put it off at the beginning, GLP-1 is still extremely vital for appetite. So GLP-1, as some people know, it's a hormone that we produce inside of our gastrointestinal tract. And the thing that stimulates the production of GLP-1 is when specific cells in our intestinal tract interact with food molecules. So glucose, fatty acids, amino acids, and another molecule called a short chain fatty acid, which is produced actually in our gut microbiome after we consume dietary fiber. So dietary fiber is one mechanism that can also increase the production of GLP-1, but it's essentially the interaction of food molecules with specific cells in our intestinal tract that stimulates the production of GLP-1. And it's almost acts as a signal that we've consumed food and there's enough food floating around that we don't need to continue to consume. So GLP-1 is a fairly appetite suppressive hormone. It also has other benefits that we've seen a lot with the new medications that mimic GLP-1, such as helping to lower blood glucose, helping to be anti-inflammatory, and having benefits for things like the cardiovascular system. But the big thing that I've seen more research coming out now that isn't very well discussed is the fact that the cells that produce GLP-1 are located slightly farther down in the intestinal tract. So they're not located in the upper part of the small intestine, or they're not as concentrated there. They're concentrated more in the lower part of the small intestine and into the large intestine. This is important because when we're eating very rapidly digested foods, it decreases the amount of GLP-1 that we would release in response to that meal. So foods that digest very rapidly, things like juice or very simple sugars or dietary oils, they can be they stimulate the production of GLP-1 to a lesser extent than something that is a little bit more difficult to digest. We're thinking things like whole proteins, fats that are found in the food matrix, whole grains, things with dietary fiber that slow down and prolong digestion. So things like that appear to be the most potent for stimulating the production of GLP-1, simply because by the time that they are digested enough to be absorbed, they are in the area of our intestinal tract where we would produce GLP-1. So that's one thing that can help a lot of people with satiety is stepping away from the liquid or more simple sugars or the liquid calories and eating foods that are a little bit more difficult to digest and may contain more components that would slow down and prolong digestion.
Yeah, the GLP-1 I think is just super interesting. Again, a lot of people you ask in the fitness industry, it's like back and forth on it. I think it could be super helpful. And I'm sure, again, we'll dive into this with the whole appetite talk. But man, I do think it is very helpful for people who are, again, overweight, just because, again, I think as a whole, like their appetite system and everything is just out of whack. Could you maybe hit on that a little bit as well, too, in terms of as you get to these body fat levels, whether it's too low or too high, how that can impact your appetite and stuff like that?
Yeah, if we start off with high body fat, two of the hormones that we've already discussed, being leptin and insulin. Both of those have appetite suppressant effects. But as body fat, we accumulate more and more body fat, we become more and more resistant to both leptin and insulin. So those can decrease both our baseline level of, sorry, they can increase our baseline level of appetite and decrease the satiating response to a meal of an insulin increase. It seems like having excess body fat, although we may be producing a lot of molecules that should be telling our brain or should be dictating that we eat less food, we're becoming more and more resistant to those molecules. So it's becoming more and more difficult to actually, for our gastrointestinal tract or our body fat, to signal to the brain to suppress our appetite. And at low levels of body fat, because we have very low body fat, we're producing much less leptin. So during the day, even though we may be extremely leptin sensitive, we're just not producing much leptin in the first place. So we would still be hungrier at baseline. And there are other things, mainly we have lower productions of insulin anyway when we're consuming less calories, that also may play into increasing our appetite slightly after a meal, because the smaller the meal is and the lower the carbohydrates are, the less of an insulin increase we would get, and the sooner we will be hungry after that meal. So a lot of times the reason that people at low body fats are very hungry is in part dictated by the low body fat, but also dictated by the behaviors that are allowing them to be at that body fat. So not eating much food, having a low carbohydrate allotment, and sometimes even having a lower allotment of protein and dietary fat. Those things can also have detrimental effects in the fact that we just aren't consuming as much food as our body wants us to consume. So we may have, so food will be in the intestinal tract for a shorter amount of time. So one of the things that dictates hunger is the amount of food inside of the intestinal tract and the distension of the stomach. So as the stomach begins to get distended, that sends a signal to the brain to suppress appetite. If we're eating smaller meals in the attempt to continue to lose body fat or maintain a very low body fat level, the speed at which food goes into and out of the intestinal tract will be more rapid, and we will have a shorter duration of appetite suppression after a meal.
What, as we're talking about this, what would you say is muscle's role in this as well too? Is muscle going to impact appetite in any way?
There isn't a ton of research on muscle when it comes to dictating appetite. The only thing we can see is that after exercise, there are specific molecules released by the muscle called myokines, and there are also just specific metabolites. One that got a little bit of traction, I believe 1 or 2 years ago, was called LACPH or lactoyl phenylalanine. It's essentially a molecule of phenylalanine bound to a lactate molecule that if we inject mice with the specific molecules, it suppresses their appetite. And that molecule in serum is upregulated after exercise, namely high intensity exercise. So the more lactate we're producing, it appears the more of that molecule we produce. And that could be one of many factors that dictate the kind of appetite suppressive effects of a high intensity workout, at least for the transient period after the workout. It's hard to go do something extremely intense and then go sit down for a big meal afterwards. You have a brief period of appetite suppression, and that appears to be dictated by some molecules that are produced by the muscle or released by the muscle during exercise, and that may be upregulated by higher intensity exercises too. But there actually might be a slight effect for muscle to increase appetite a little bit. And that is that one of the things that we know is that muscle is one of the largest sinks for glucose. And one thing that does have a dictatorial effect on our appetite is the amount of glucose in our bloodstream. So if after a large workout or after a long workout, we consumed 150 grams of glucose or of carbohydrates, we may lower our blood glucose back down to normal a lot more rapidly than we would have if we didn't have much muscle mass or hadn't worked out. So that may almost cause that meal, our satiety after that meal, to be a little bit less prolonged. So it may shorten the duration of our suppressed appetite, just given to the fact that our muscles have consumed some of that energy in our bloodstream that signals to the brain to suppress appetite slightly. But in those people that have larger muscle mass, this isn't necessarily a bad thing, because they just require more calories at baseline anyway because of the excess muscle mass. So it's not as if having more muscle mass will make you more and more hungry. There's the benefit of muscle mass on overall energy utilization and caloric expenditure outweighs the slight increase in appetite that it may provide you, if that makes any sense.
Yeah, it makes a ton of sense. Just anecdotally working with clients, it's like once we Obviously a lot of people do need to lose body fat, right? A lot of people also need to really work on adding lean body mass as well too. And I just find that when we do that, and obviously adding lean body mass requires, you can't just go super low calorie and you have to be strategic with your nutrition. I just find that, again, like you said, maybe for some people it can increase hunger a little bit, but again, most people need that extra fuel. And I just find that the body just seems to be more there's just less friction from a body comp standpoint and change and stuff like that when you add muscle. And I think at the very least, it can be a great way to help manage your weight long term, even if it doesn't necessarily always lead to like weight loss. I don't know if that has anything to do with what you said, but that's just what I've seen anecdotally working with clients. I don't know if that's something you've seen as well too.
Yeah, absolutely. There's a multitude of things that muscle does to benefit our body composition. So it essentially acts as a glucose and in part a fatty acid sink. So there's intramuscular triglycerides that we can store. So having more muscle can partition specific fuels or the amount of calories that we consume towards muscle rather than towards fat tissue. And as you may know, it slightly increases, not a ton, sometimes it's over exaggerated, but slightly increases our metabolic rate at rest, and it increases our metabolic rate through all the activities we're doing. So if a bodybuilder ran a marathon, he'd burn far more calories than a marathon runner. So someone with more muscle mass will expend more calories doing the same things. So it helps a lot in the energy partitioning process. So even if it may very slightly increase appetite, the additional energy likely will not be partitioned. It makes it less likely the additional energy will be partitioned towards fat tissue and more likely that it will be partitioned towards muscle utilization, energy storage, something like that.
When most people, and again, this could come back even to like people taking GLP-1 and stuff like that, and people that most people when they get into fitness and nutrition and stuff, they want to lose weight, right? One of the things we really hit on is like making sure, hey, that we're at least at the very least maintaining our muscle, right? So we want to weight train. If somebody maybe doesn't have the greatest kind of methods during fat loss or the weight loss process, how does like losing muscle impact appetite?
It's difficult to answer. I would say I haven't seen much about the role of muscle gain or loss on appetite. It seems so exercise has an effect where it allows for better coupling of energy expenditure and appetite. What that means is those who are very sedentary, which would induce muscle mass loss, appear to have appetites that are higher than their energy expenditure. So they, on average, consume more energy than they expend. And one of the reasons is because they are sedentary. And then as we begin to exercise, although it may have some positive, so it may positively increase our appetite a little bit. However, the amount of energy that we expend during exercise is greater than the amount it increases our appetite. So it couples our energy expenditure and our energy intake. So I think a lot of the things we think about, like body fat does this or muscle mass does this. And a lot of times it's not necessarily a tissue itself, but it's the things that are required to preserve, lose, or build a tissue that also are one of the main reasons why we can point at specific things. Losing muscle mass typically means we're being less physically active. We may be eating a little bit less protein and more higher palatable foods. Things like that can just increase the amount of energy we consume. And as we may or may not discuss, protein does have, to a certain threshold, protein has a satiating effect. If we're losing muscle because we're just not consuming protein-rich foods and instead we're consuming foods that are high in carbohydrates and fats, that could increase our appetite just because we're not getting the satiating benefits of protein. So the things that are required to lose a lot of muscle may be in part things that will increase our appetite.
That makes a lot of sense, right? Like you said, it's not necessarily the losing of the muscle. It's, hey, the things that you're doing in that process are probably playing a bigger role than that. But again, it's a combination of things, right? I like the protein example. And then also, again, I'm thinking about this. Usually if you're losing muscle, it's probably pretty drastic calorie deficit, right? And then again, those are going to be the bigger things at play than the muscle itself. And then, like you said, exercise in general, obviously you need to lift weights. That active exercising couples that energy expenditure and energy intake as well too there. So let's hit on protein. What is protein's role in appetite?
Yes, one thing that protein does quite well is it stimulates the production of GLP-1. Of the macronutrients, it seems like protein and slower digesting carbohydrates that make it down far enough in the intestinal tract are the most potent for stimulating GLP-1. So one thing that protein does right off the bat is it might increase the production of that appetite suppressing hormone. There's also a slight insulinogenic effect of protein compared to dietary fat. So it may also increase the production of insulin, which once again in a non-insulin resistant individual may have a transient satiating effect. Another thing that protein does, it appears that specific amino acids inside of the bloodstream can either increase the production of signaling molecules or directly enter into the brain and act as signaling molecules for a reduction in appetite. So the exact mechanisms by which having higher levels of amino acids in the bloodstream, in which that suppresses appetite, is still a little bit vague, but it appears that, so for just to simplify it a little bit, protein is broken down into amino acids, and after that meal, we have a large increase in serum amino acids, so the amount of amino acids in your blood. And certain amino acids can have appetite suppressant effects. Not all of them, or at least we don't have data on all of them, but certain ones, namely leucine, which is important for a multitude of things, such as building muscle. But leucine itself also appears to have, unfortunately, there's a bit of a paucity of literature on the exact mechanisms, like all of the mechanisms by which protein can satiate appetite. But it seems like increasing blood amino acid levels is one of the ways it does this, along with increasing the production of different hormones that also suppress appetite.
So with that, with protein, one thing I see is people just really over protein like their diet. Do you think you can do that, or is there this threshold of, hey, this should get it, or is that something that we don't know for sure yet, and it could be also dependent on the individual as well too?
Yeah, it's a little tough to answer. So we have some kind of conflicting data. So one that has got a lot of traction was one by Dr. Jose Antonio a few years ago. Essentially, he fed participants 4.4 grams per kilogram of protein. Sorry, yeah, 4.4 grams per kilogram, which is about 2.2 grams per pound. And he saw that it was really difficult for his participants to eat that much protein because they felt extremely satiated. So that was one thing that allowed us to come up with the hypothesis that eating more protein may have an appetite suppressive effect. But there's been not a lot, but a few studies that have directly compared a meal containing protein versus a meal containing just carbohydrates and no protein. And there actually hasn't been that much of a difference in the manner in which they suppress appetite. So whether or not it's just because we are going crazy on a specific macronutrient and leaving the other ones astray, that we might be having a suppression appetite, or whether it's a specific effect of protein is still a little bit, but it seems like there is more data leaning towards the idea that having a higher protein percentage, so this is important as well, having a higher protein percentage of your diet has an appetite suppressive effect. So we can eat more protein while simultaneously eating a lot more calories, and the protein percentage of your diet may stay exactly the same. With that being said, if we begin to reduce carbohydrate and fat intake and increase protein intake, we may stay at the same amount of calories, but the percentage of calories coming from protein would increase. And it appears that is somewhat potent at suppressing appetite compared to just increasing dietary protein, because we could be doing that from low protein foods. And at the end of the day, we end up in a caloric surplus, even if we're eating 150 grams of protein. So it seems like protein percentage is a part of the picture.
Yeah, that's a good point you bring up, the protein percentage, because like you said, a lot of times you tell people to increase protein, and what do? They usually, like you said, they either just increase it with low protein type foods, or it's usually proteins that are higher fat as well too. And now that's going to increase your calories, and that's not going to have the same effect as increasing the percentage of protein related to the calories, which I think that's why with clients, really try to have them focus on, if you don't necessarily want to track all the macros, that's fine. But it's like, hey, probably calories and protein are going to be the way to go, because again, that can help you work on that percentage there as well too. Cool. Okay. So the next one was just like thirst and dehydration. How does that impact appetite?
Yeah. So as we talked about a little bit, one of the things that dictates appetite is gastric distension or expansion of the stomach. And there's some good literature indicating that drinking a glass of water prior to a meal, because it essentially pre-stretches the stomach, it will reduce caloric intake in that given meal. So it seems that having at least liquids present in the stomach when we're eating may cause early satiety or reduce the amount of calories that we eat in a given meal. And the water content of foods may mean that we can eat a larger volume of food while still reducing calories, because if a food is 50% water, that's essentially 50% of that food that isn't providing any caloric content. So the higher water content foods like leafy green vegetables, fruits that are higher in water content like watermelon, those appear to also have an appetite suppressive effect, just because water or liquids themselves can just fill up space in the stomach that could be. And the other thing, it seems that dehydration, whether or not dehydration increases our appetite for food, is still a little bit, again, it's another thing that's a little bit unclear. But we do see that, as you may know, dehydration radically increases your desire to consume liquids. Sometimes those liquids may not be in the form of water. A lot of times, if we're super dehydrated, we may go for a Gatorade, a juice, something like that, that also brings along calories. So by the sheer fact of just consuming more liquid, if we're consuming it from calorically dense liquids, then that could just increase our appetite without really altering our appetite that much. So liquid calories themselves appear to be a little bit less satiating than whole food calories. So probably the meanest study I've seen done in the past few years was they compared whole chicken breasts to a chicken breast shake, and they found that those consuming the whole chicken breast were more satiated than those consuming the same exact amount of water and chicken breast, but in the form of a shake. So there is a slight edge for whole foods for suppressing appetite, but if we're looking at non-calorically rich liquids, they can essentially replace gastric volume that would be given to calorically dense foods.
Makes sense. Yeah, that sounds nasty. Having a chicken breast shake, I couldn't think of anything worse than that. So cool. Yeah, no, that makes sense. Again, like it's with the dehydration, that's obviously your body's gonna be like, hey, we need to consume liquids. And so if you're consuming those liquids via, say, soda or again things that have calories, and then that's where that could start to add up, because that's also not going to lower your hunger or anything like that as well too. So that makes sense. Another big one that you had in here was the presence of food. I think this is super interesting too, right? I think a lot of times the big thing I think of here is just like having clients, like if they go out to eat at restaurants or if they have an event where there's a lot of food around, that can also be something that impacts things. I'm curious to hear a little bit more about that.
Yeah, so our environment dictates not just when and how much we eat, but also the things that we choose to eat. So if you're walking through a clothing store, you're not really thinking much about food. But if you're walking through a grocery store, you may start to think about food, and you may realize that you're hungry if you're walking through a grocery store, whereas you wouldn't realize it if you're engaging in something at a clothing store or something like that. So the food in our environment can act as a signal to the brain to just begin thinking about food, which may stimulate an appetite or desire to go obtain food. If you're walking through a house that is enriched in ultra processed foods that you know and have experienced taste extremely good, you may end up snacking more often than if you were walking through a house that had basically no snacks and no ultra processed foods, just fruits and vegetables and things like that. You may snack less, not because you're any more or less hungry, but because your desire to consume an apple may be lower than your desire to consume a package of Oreos or something like that. So the specific foods in our environment can dictate, our drive to consume, whether or not it be via hunger or just be because we know something tastes good and that in and of itself is rewarding. And then the presence, sight, and smell of food may also increase our appetite compared to if we weren't even, our mind was on a different topic, if that makes sense. There are specific molecules that are basically play a role in the motivation to obtain something. And if that motivation to obtain something is driven towards food, then we would go obtain it. But we can also divert our attention and motivation towards something that have nothing to do with food. And for that period of time, our mind is off of food and we're not consuming. The most easy to understand, but still slightly unfortunate example would be things like drugs. We see that a lot of specific drugs, the ones that don't stimulate appetite, can cause people to lose a lot of weight because they're so focused on obtaining that given drug that they are less focused on obtaining food, or they are getting their reward from a drug rather than from food, and they begin losing weight. So that's why oftentimes specific drugs like nicotine or cocaine are associated with weight loss, because their attention and their focus is on essentially a different appetite in a sense than a food appetite.
That's interesting. Is there anything you can do to, like, obviously, outside of extreme examples of like, taking cocaine or nicotine, is there anything you can do to quote unquote, hack that process if you are, someone that, again, I mean, you're just in that environment where there's, that presence of food there. And again, you have these body comp goals. Is there anything that you have found to be super helpful or in the research that says, this could help or anything like that?
Yeah, there's definitely some data on the food environment itself. It's tough for some parents because there are reasons why parents might have food that isn't on their specific diet plan or may force them to go over in calories if they decided to consume it, that they have present in the house for children's sake. Whether or not you want to change their food environment as well as yours is completely a parent's choice. But if you're, let's say you're living by yourself or with a significant other, just changing the food environment can decrease your caloric intake and your appetite. So taking out foods that you know are extremely palatable and that you have an easier time over consuming, even if you're not necessarily hungry, because in reality, most people could eat a donut if they are or are not hungry because it tastes good. But if you're in an environment where you just have fruits, vegetables, kind of things in the fridge that may not even be prepared yet, so you have to go through the effort of preparing it, those things can just decrease your motivation to consume or to snack or something like that. And then some people may have realized it during the pandemic and the lockdown period is they were in their house a lot and they didn't have much to do. And a lot of people, unfortunately, they gained a bit of weight because one, they were always surrounded by food, and two, they didn't really have much else to think about or much else to do other than be in their house and go rummaging through the cabinets or the fridge. So having a specific thing that you're focused on that isn't in relation to food can transiently keep your mind off of consuming food. So whether that be exercising, as some people may know, if they're doing something, a difficult task at work, they're not really thinking about when their next meal is going to be. They're thinking about whatever it is that they are trying to complete or accomplish. Having a specific activity or something that you're doing can help pull your mind away from, I'm bored. One thing I do when I'm bored is I go look for food.
Yeah, those are all super helpful. One that we briefly touched on earlier, but I think is super important too, is your current energy balance, right? Like you said, kind of presence of food. I'm assuming that's something that is also going to impact things, right? Because it's, again, we talk about body fat, like too high, that can impact your hunger, too low, that can impact it. But then also within that, to me, that's like long-term energy balance, whereas like the short-term energy balance of current energy balance that you're in, whether that's trending in a deficit, maintenance, or surplus, that's going to have a huge role in terms of appetite as well too, correct? And I'm assuming that even within that, genetically, some people are that's going to impact them differently. And then on top of that, obviously all the things we've talked about can also impact your appetite during that as well too.
Yeah, so the presence of nutrients in the bloodstream is one factor that can suppress or increase appetite. So we see that elevations in blood glucose, not only do they increase the production of hormones that suppress appetite, but glucose in and of itself can also act as a signal to suppress appetite. So having high levels of nutrients in your bloodstream, say after a meal, or if you are just in a caloric surplus and there's more fuel in your bloodstream that you can take up and store or utilize at that given moment, you may have elevations in your blood nutrient content, which transiently suppresses your appetite. Conversely, if you have low blood glucose or low blood amino acids, that can be something that stimulates appetite. There really isn't any good data on there isn't any good evidence that serum fatty acids or the amount of triglycerides in your bloodstream would also increase your appetite. However, we know that radically suppressing blood triglycerides or serum lipids doesn't have any effect on appetite. So we see that with using anti-lipidemic agents where they may take your serum triglycerides down below the reference range, and that doesn't have an effect. But taking your blood glucose down below the reference range, that would radically increase one's appetite in many cases. The severity of low blood glucose would alter your actual response because at extremely low blood glucose, you would be more so worried about keeping your heart from beating out of your chest than going to find food. But small decreases or dips in blood glucose may stimulate appetite slightly. The nutrients in your bloodstream can also dictate whether or not you do or do not want to consume food. And that can be dictated by the amount of food that you're eating in a given day. So starting off your day with a larger breakfast, specifically one higher in protein, does appear to have an appetite suppressing effect for the rest of the day. Whereas if we fasted, our appetite in the later portions of the day may be higher than if we had consumed something already.
Yeah, the one there and most people typically eat opposite of that, where they're usually not eating very much early in the day and then they eat later. And then, like you said, the protein aspect of it is super important in the day as well, too. So cool. Super interesting. One more on like the more physiologically, I cannot say that word right now, side of things is sleep and stress. How is that going to impact things?
Yeah, so there's a few things. So stress and sleep can increase the production of cortisol, and there is a mechanism by which cortisol can stimulate appetite. So it's it's easier with a graphic or a diagram, but the production of cortisol starts in the brain when the brain produces a specific molecule called CRH. And CRH itself actually has an appetite suppressive effect. So the beginning stages of the stress response appear to actually suppress appetite, which might make sense because if it's an acute stressor that comes and goes, during that stressful period, whatever it may be, it would make sense if we have reduced appetite. But cortisol, which is the downstream consequence of an acute stressor, so a physiological or psychological stress, that has an appetite suppressive effect. So maybe it seems like after the initial stress response, when we have higher levels of cortisol in the bloodstream, but lower level of CRH production by the brain, that's when stress may have an appetite increasing effect. So it seems that the data, it's actually a little bit clear that it's not a 50-50 mix, but it's very heterogeneous as to whether or not someone loses or gains weight in a period of prolonged stress. So how it affects you might be different than how it affects me. So there's no way I can put a blanket answer on to what stress does. And sleep loss or sleep restriction does a very similar thing. It can increase the production of cortisol, but it can also, both stress and sleep loss can induce resistance to both leptin and insulin through a secondary loop, can increase appetite by altering the functionality of those appetite suppressing molecules.
I'm glad you brought that up about the stress, right? Because I think a lot of times people think it is like, oh, hey, it's going to increase hunger when that's not necessarily always the case, right? Like I know for myself specifically, when I'm in times of higher stress, I definitely see that like hunger go down, right? Like for me, it's, hey, I need to like make sure I'm eating enough. Whereas like you said, some people on the other end, like they're super hungry and it can impact them. But it really does depend on you. And I always say under high stress times, it's like learning how your body reacts to it, I think is super important. Again, I'm sure that all these things that we've talked about today also are going to impact that as well too, in terms of if you're just eating highly palatable foods, that may be something that even if naturally maybe you aren't going to be as hungry under high stress times, that may impact that. So again, all these things are going to play a role. I know we saved this for the last, but like the psychology side of things, is there anything that you want to hit on here? Anything big that you want to let the audience know about the psychology side of things from an appetite perspective?
Yeah, so we talked a little bit about kind of the food environment. So that's one big part of it, is the foods that you're surrounded by and the foods that, your sight, smell, things like that of food can dictate your appetite. There's some stuff that would be almost more so geared towards someone like an actual psychologist, but the way that in the past, whether or not you have or have not utilized food as a comforting device, that can be part of whether or not you look towards food during a stress response or not. Because if you have other mechanisms to cope with stress, again, that stress may suppress your appetite or cause you to focus on something different. Whereas some people who may have gone towards food when they were stressed in the past or were brought up that way, that could be something that could be different. Those might be the people that increase their food intake in response to stress. So your past and the way that you viewed food in the past may be part of it. The food environment. There's also the specific foods that you're consuming can have higher or lower palatability. People like hyperpalatable foods are foods that have a mixture of specific things that are very stimulating for the brain. So typically they're a mixture of either carbohydrates and salt and fat, fat and carbohydrates, or a mixture of the three. So salt, fat, and carbohydrates. So the mixture of those three makes a food what we would consider hyperpalatable, which is basically easier to overconsume, even in the absence of physiological hunger. So your ability to eat 10 apples is less than your ability to eat 10 donuts, even if you are consuming more calories, and they might be filling up a similar space in your stomach. The reason is because those donuts have a palatability factor that apples might not, depending on the person, that apples typically don't. And it'd be easier for you to just keep eating donuts rather than continuing to eat apples, which have a lower palatability. As much as I would never want anyone to purposefully only eat bland food, eating foods that you know are extremely palatable for you and they're foods that you have a tough time regulating, reducing or eliminating those can be beneficial, or restricting yourself to specific allotments of them instead of just eating as much as you can until you feel full. So things like that, like the foods that are very palatable to me may be different than the foods that are palatable to you. There seems to be a trend of people saying that steak is what they're craving with those people on the carnivore diet. So not that I'm recommending that, but those people may see palatability of foods completely differently than someone who is eating a very processed diet. The things that you or I find very satiating or very palatable and easy to overeat will be different. But on average, there are things that are a mixture of specific nutrients that we personally find are quite stimulating. So again, those hyperpalatable foods that we talked about, which for the most part are just the packaged and processed foods that kind of people demonize anything that's in a package or anything that's processed. And I think the reason that I personally, stay away from them or recommend people stay away from them isn't because there's anything wrong with the way that they're not going to poison you or anything like that, but they're just much easier to overconsume.
Yeah, and if you're not aware of that, again, it's just going to be really, like you said, really hard to moderate it there. And with those types of foods, it's if you are going to have them, you almost have to force yourself to stop. Otherwise, you're probably going to end up getting to the points where you may overconsume those. So yeah, super interesting. Even within that, like you said, it also really depends on the person in terms of what you find to be super tasty. Again, that's not necessarily the same, but I'm sure that comes down to like your preferences, your what you've had in the past, and all these things there. Cool. Calvin, a ton of stuff in here. I think somebody listening to this, they could be like, man, that's a lot. There's probably a lot going on. I think again, that comes back to the title of it, right? The fascinating, sorry, let me just pull it up real quick. The fascinating, this was a long article. Sorry, I'm rolling to the top. Hold on. Jeez. This is taking longer. Hopefully we'll edit this out. The physiology of appetite regulation. Again, that's basically where we finished at here with that, right? That's definitely the case. So I guess for you then, if you could give maybe some practical applications here. Again, you don't have to go into every last single one because again, that could probably be a whole hour conversation. But what would you say are the big ones and like maybe the take home things that you would have for the audience take home here with this topic?
Yeah, so the most practical tips that I've been able to give in the past that seem to work are the majority of the population responds or is more satiated and eats less calories if they consume a larger breakfast. Within that, a larger protein and fiber breakfast also appears to be beneficial. So, eating some food in the beginning of the day to start off your day, even if you're not necessarily extremely hungry, is a way to keep yourself from getting extremely hungry at the end of the day. Increasing your just dietary protein and fiber in general has an appetite suppressive effect. Increasing your consumption of polyphenols, which come from colorful fruits and vegetables. Those polyphenols have signaling properties, whether they directly increase GLP-1 or they can also increase the production of those short chain fatty acids, which also increase GLP-1. So eating more colorful fruits and vegetables, eating foods that are higher in water content. So again, fruits and vegetables, which are typically low energy density. It seems like eating foods that are a little bit more difficult to digest and less processed appear to be better for suppressing appetite. And then overall, just consuming a diet that is more nutrient dense. So typically you're going to just get that from eating whole unprocessed foods or just foods that haven't been refined into something that may rid them of specific nutrients. So eating more micronutrients and then all of the things that we discussed in the sense of consuming less liquid calories or consuming more calories that are, I'm not sure the best way to say it, but that are difficult to digest, I guess. I'll say it again. I think there was one other thing, but I'll probably come later.
Hey, you've given us a ton of information here. Totally understandable if you can't remember that one. Yeah, I think those are great tips. And again, things like you said, just probably take you longer to chew and you really have to slow down. And those highly palatable foods, unfortunately, do the opposite of that. You can just scarf those down super quick. Cool, Calvin. We'll really appreciate your time. We're definitely going to have you on here again in the future. This is a topic that an hour is not going to do it justice, but I just wanted to get you on here to give everybody a just nice kind of general outline of this and obviously to go continue to check out your information. But like I said, we'll definitely get you on again in the future. Before I let you go, is there anywhere where you want to lead the audience to and where they can find you and things like that?
Yeah, my Instagram is Calvin_Scheller. So you'll see a bunch of videos, any podcast or article I've written, I'll typically put on there. My TikTok, which is growing, is called Physiology with Calvin. That's another place where you can find thousands of videos, probably about 1,000 or 1,200 videos that I've made on just physiology in general. And then recently, I've started contributing articles to a website called The Educated Dieter. So there should be 4 articles on there at the moment that I've written that are free to access. Anyone can read them. That may also be questions that people have that or interesting topics for them to read that can give you a little bit more information. And mind you, they're in depth, so it might be a little bit long.
But a ton of information. So awesome, Calvin. Really appreciate your time, man. Again, super impressive, like your knowledge and everything like that. And again, you're only 19 years old, so it's only going to continue to improve. I can't even imagine what it's going to be like in even like two years from now. So again, we'll have to keep getting you back on here, man. Again, appreciate your time and we'll talk to you soon.
Thank you for having me on, sir.